Okay, example 3. We're cooking now. Determine the solution set for the inequality x plus 3 over x plus 1 greater than x minus 2 over x minus 3. Aha. So a fun looking question, to be sure. Now we're going to follow the same technique. We're going to bring everything to one side and get a common denominator. Whoops. X minus 2 over x minus 3 greater than or equal to 0. Now we'll have to multiply. Our common denominator will be x plus 1 times x minus 3. So in effect we can multiply both sides times x minus 3. So we will have x plus 3 times x minus 3 minus x minus 2 times x plus 1 all over x plus 1 times x minus 3 greater than or equal to 0. And again, we're keeping these denominators because these may be key points where there's a sign change, and so we need to be aware of that. If we get rid of these denominators, then we may lose part of the answer. So we have to do some expanding here. Disregard the arrow plane. So this is a difference of squares, if you notice. So that's going to be x squared minus 9. That's nice. And this one is less fun. X squared, that's going to give us negative x and a minus 2. Keeping our denominators greater than or equal to 0. To clean this things up, we'll have x squared minus x squared, so that's nice. These will cancel. And then what will we have? We'll have negative a negative x. We're going to have just x, and then we have negative 9 minus negative 2, negative 9 plus 2. That will be x minus 7, if I'm not mistaken. Hopefully I am not. Stop doing that. Alright, so it's simplified down rather nicely, and so we can see our key points. Right, we have restrictions in the denominator here. Remember these vertical asymptotes, if we were to graph these rather nasty rationals. So the key points being x equals 7, negative 1, what makes this 0, and what makes this 0? 3. So these are the key points. So we follow the same procedure. We throw down our number line. We're going from negative 1 to 7, throw the 0, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. I guess I could just number them. Negative 1, 2, 3. Okay. Now we indicate our regions. So 7 is a key point, negative 1 is a key point, and 3 is a key point. So we are looking for the regions. When is this expression greater than 0? And so we test. X equal, well, let's go from the left this time, shall we? X equals negative 2. And so when x equals negative 2, we will have a, well, maybe I'll rewrite it over here. That seemed to work well. Over x plus 1 and x minus 3. So when x equals negative 2, we will have a bigger negative, and a negative 2 minus 3. So a negative divided by a positive is a negative. Okay. And let's test out, 0, 0, 0 is always nice. We will have a negative divided by a positive times a negative. That is a negative divided by a negative. That is a positive. Testing out 5. Negative, positive, positive. Negative divided by a positive, negative. And we can test out 8 for the last region. That's 8 minus 7, that is a positive. 8 plus 1 is a positive, 8 minus 3 is a positive. All positives give us positive. So it's looking like we are concerned with, remember, this is greater than or equal to 0. So 0 is included in this. Now we need to be careful because at -1 and 3, we can't actually have those values in the domain. So our region becomes greater than 0 is when x belongs to the region. Now we can't have -1 and 3, so we'll be between those regions. Greater than -1 to 3, and 7's included. We can have 7 in our expression. That's alright. So it actually equals 0. If we put in 7, we'll have 0 divided by the denominator, which gives us 0. So the other interval would be, square bracket, hello, square bracket, 7 to infinity. That's my train. I must go.